Under square roots today, we are looking at the product of square roots. For example, if I have this, the square root of 3 times the square root of 12. Now you have to be a little careful with this, okay? If I had the square root of 3 plus the square root of 12, I can't add those together. Okay, you have to think about square roots just like they're letters. Okay? If I have an x and a y, I can't add those together because they're not like terms. Same thing with square roots. Okay, you can't just add them together and get the square root of 15. But if I multiply them, if I have x times y, can I multiply those together? Yeah, I get xy. Same thing is true with square roots. Square root of 3 times the square root of 12 is the square root of 36. You can multiply them together by multiplying just like normal. Okay? Square root of 3 times square root of 12, square root of 36, 1 times 12. Okay? Then, once you multiply it though, you have to see if you can simplify that. Can I simplify the square root of 36? Yeah. Square root of 36 is 6. So that would be your answer to that. They don't always work out nicely. For example, if I had the square root of 42 times the square root of 24. Square root of 42 times the square root of 24. Now, I'm going to do this out, and then I'm going to hope you can think a little bit about this and see why it's a little redundant to multiply this out. What do I get when I multiply the square root of 42 times the square root of 24? Well, 42 times 24 is 8, 16, 0, 4, 8, 8, 0, 1008. I get the square root of 1008. I hope. Anybody else do that?
Yeah.
Get that answer? Now, can I leave the square root of 1008? No, I have to simplify the square root of 1008. Do you remember how to simplify square roots? What was your first step? Somebody help me out there? You had to prime factorize them. We just did this. Okay? Which means I have to break this down into prime numbers and see if I get pairs and matches. Okay? Now, here's a question for you. What times what gives you 1008? Some of you are thinking a little too hard about this because where did I get 1008 to begin with? So what times what gives me 1008? Okay, so you could skip the whole multiplying together thing because in order to see if you can simplify, you have to break it down anyways. Okay, so really I should have jumped right into this by starting with taking those two factors and prime factorizing them. Because I'm going to have to do it anyways. If you like to multiply and you want to do that, that's fine, but you're going to end up breaking it down anyways. This is the square root of 6 times the square root of 7, correct? 24 is the square root of 4 times the square root of 6. 6 is the square root of 2 times the square root of 3. 7 is prime. 4 is the square root of 2 times the square root of 2. And 6 is the square root of 2 times the square root of 3. So I'm left with the square root of 2, 1 square root of 2, 2 square roots of 2, 3 square roots of 2, 4 square roots of 2, square root of 3, the square root of 3, and the square root of 7. Correct? That's all my prime factors. How does it break down from here? Well, 2 square roots of 2 give me a normal 2. Another 2 square roots of 2 give me another normal 2. 2 square roots of 3 give me a normal 3. The square root of 7 has no pal, so it stays the square root of 7. I remultiply them, and 4 times 3 is 12 times the square root of 7. Stop me there if you didn't do this. We did this probably, what, last week or this week? Monday maybe? Last week? Okay. And once again, people, if you're mathematical, maybe at this point right here, you could have saw, if we would have stopped right here, could I have gotten that same answer? Yes, because what do I have here? A square root of 6 and a square root of 6, which would give me a normal 6. Square root of 4 is 2. 6 times 2 is the 12, and I still had that square root of 7 over there. If that makes sense to you. But if it doesn't make sense to you, you kind of got to break it down all the way. How about another example you say? Why not? Square root of, or 3 times the square root of 6 times 15. What's the deal with that? Okay, it's the same thing we just talked about. You can multiply 6 times 15 and get 3 times the square root of 90, which is what that would be. But then you have to try to factor out the square root of 90, so you end up redoing what you just did. Your call. If you want to break it down a different way and say it's the square root of 9 times the square root of 10. Okay, but you cannot forget about this normal 3. In the end, in your end of your answer, you got to tack that 3 onto whatever you get for an answer. Alright, the square root of 9 is the square root of 3 times the square root of 3, and the square root of 10 is the square root of 2 times the square root of 5. What do I get? 2 square roots of 3 give me a normal square root of 3. These two don't have matches, so what happens to them? You remultiply those together, you end up with the square root of 10. 3 times 3 is 9 times the square root of 10. Gary is looking questioningly at that. Everybody happy? Because I have to go over one more thing that's going to blow your minds. And you don't want your minds to be blown, do you? Sure, let's do this. Draw this rectangular coordinate system here, because the book does a lot of this. It'd be nice if you had some squares that you could do this, but I guess. This is still under square roots, yes. The book gives an example that says 2, 2, 1, 2, 2, 2, 0, 4, 1, 2, 3, 4. This is 2, 2. This is 0, 4. Negative 1, negative 1. And it says negative 3, 1. Got that? Find the area of the rectangle. I can tell you're very excited about this and highly emotional. Anybody want to throw at me what the area of that rectangle is? In order to find the area of a rectangle, what do I have to multiply together? Area equals what of a rectangle? Length times width. So in order to be able to do this problem, children, I need to know what a length is and I need to know what a width is. How do I find the length and the width with that? Jacob, think outside the box here. Do I just guess as some of you do? No. Guessing will not. Michael? Anybody? Somebody give me an idea how to find that length and that width. Oh boy. I'll give you a clue. The answer, my friend, is blowing in the proverbial wind right behind me. A little thing I like to call the Pythagorean Theorem. But that's not a triangle you're going to say, aren't you? Somebody say it.
It's not a triangle.
No, but because it's got all these rectangular coordinate systems on it, you can draw your own triangle. Take a look. If I took this line and shot straight across from here, and took this line and come straight down from here, I have a triangle here whose hypotenuse is right here. If I can find the length of the hypotenuse of that, then I have my length of my one side of my rectangle there. Well, because it's on a coordinate system, you can count this distance out because it is that a 1? 1, 2, 3 here, and this is 1, 2, 3 there. To which you're going to say, that's not a perfect, that's not one of these Pythagorean triples. Well, now that you can multiply square roots, you don't need perfect triples because you're going to end up multiplying those things together. How do I find out what this is with the Pythagorean theorem? It's a squared plus b squared equals c squared. Well, these are the legs are the a's and the b's, so I have to do 3 squared plus 3 squared equals c squared. What is 3 squared? 9 plus 9 is, somebody?
18.
And here we go again. It always falls apart here. Nobody can answer this question for me. If I have 18 equals c squared, what does c equal? Square root of 18. Remember? What number times itself gives you 18? This length right here is the square root of 18. Unfortunately, though, kids, the square root of 18 can be broken down into what? Square root of 18 simplifies into, the square root of 9 times the square root of 2. What's the square root of 9? 3. So this side is 3 times the square root of 2. The length is 3 times the square root of 2. Guess what? We still have to find the width, doing the same thing. Doesn't matter what side you go to, but if you go straight down from here and straight across from here, you make a rectangle here. It is a 2 by 2 rectangle, or triangle, sorry. Using the Pythagorean theorem for this, what do I get? A squared plus b squared equals c squared. 2 squared plus 2 squared equals c squared. What's 2 squared? And 4 plus 4 is? Oh no, here we go again. If 8 equals c squared, c equals?
Square root of 8.
Well, and now we have to simplify the square root of 8. It's the square root of 4 times the square root of 2. And what is that? Square root of 4 is 2. So I get, for this side, 2 times the square root of 2. Now, because you are smart, and we just talked about this, you can now multiply those two together. What do I get when I multiply 3 times the square root of 2 times 2? By the way, doesn't that sound like you're in like some heavy-duty math class? What do you get when you multiply 3 times the square root of 2 times 2 times the square root of 2? 3 times the square root of 2 times 2 times the square root of 2. Sam, you gonna take a shot at it? Yes. 12. Exactly. Sammy nailed it. There's 12 units there. Let me do that again in case you missed it. In big letters, 3 times the square root of 2 times 2 times the square root of 2. 2 normal, or square roots of 2 cross off to give you a normal 2. That gets multiplied by this normal 2 here, and multiplied by that normal 3 there. 2 times 2 is 4, times 3 is 12. Doesn't this? That's a sweet looking problem there. Doesn't it look like Einstein all over the place there? They will give you a lot of that stuff. Anytime you can't, doesn't seem like you can figure out what a line is, make a right triangle out of it. Use the Pythagorean theorem. It may not work out. It's always nice when it's a 3, 4, 5 triangle, but it may not work out. But you can use the square root of 2. It's not that difficult there. Does that sound exciting to you, to me, to everybody? Jacob?
Could you see the right triangle anywhere on the square or on the rectangle?
Yeah, as long as you go straight across and straight down. I mean, from any point you can. You are your own boss.